Hello, this is Mr. Schroeder. We are going to talk about titrations and neutralizations today. Our objectives today are to be able to predict what the products of an acid-base reaction are, talk about what the equivalence point is, and then talk about how to select indicators for a titration. A neutralization reaction is when you react an acid and a base, and when you do that you form water and a salt. So for example, HCl is an acid and NaOH is a base. When I react these together, the H and the OH on the sodium hydroxide will form water, and what's left, the sodium and the chlorine, form a salt. It doesn't have to be NaCl, in this case it was, but any ionic compound is considered a salt. When this reaction takes place in water, we actually have our HCl has, if you remember from our previous chapter, our previous section, when HCl is in water it forms H3O plus Cl minus. This H3O plus is what's actually reacting with the OH, so I can have two. This is when I'm looking at the ionic, on the ionic level, instead of an overall reaction, and including the water that was present if I looked at this HCl in water. So I'd call this the total ionic equation. For any neutralization reaction, this would be the total ionic equation. When I do a titration, this is a fancy name for the process or the procedure that I use to neutralize this acid or this base. And I will show you in class a demonstration of how one is used. But if you want to think about it, I'm just gradually adding the opposite. If I have a basic solution, I'm gradually adding the acid to it until I use up the hydroxide ions. Or if I have a basic solution added to an acid, I'm trying to use up the hydronium ions. And the point at which they're equal is called the equivalence point. This is the point in which the hydroxide equals the hydronium ion. When I perform titration, I do that when I have an unknown acid or unknown base and I want to figure out what it actually is. What's the concentration of that? And when I do that, I can find the equivalence point, usually by looking for a color change. And the solution will change colors when I use an indicator. So some definitions, you're going to need to write these down. A burette is my long glass tube, this thing, right here. My standard solution is what's been added, usually to the burette. It's the one that I know. Okay, it has been made. I know what it is. The end point is when the color changes. And a titrant is the solution of the known concentration used to do the titration for the unknown. Usually I use the standard solution can be the titrant. That's the thing that goes into the burette. Okay, it's placed in the burette. So when I'm actually doing a titration, if I could measure the pH the entire time, I would see the following happen. In this case, I'm at a pH below 1, so I'm starting out with an acid, and I'm adding, as I begin to add my base to it, at first not much changes because there's still so much hydronium in there that I don't see a very fast change in the pH. As I get closer to the end point, it begins to increase much more fast, and when I reach the equivalence point, this would be when the color's changing, and I have a very, very steep curve right here. So the titration is exact if the equivalence point can be accurately detected. I'm going to use the indicators to tell me when my equivalence point is. Okay. Indicators all have what's called a transition range. This is when the color change takes place. And you've used some indicators in class already. You've seen some color changes when the pH changes. But there are several standard indicators that we can use. If I look at something like this methyl violet, it changes colors at a pH around 1. Thiamol blue changes colors from pink to yellow to blue, and somewhere around this 7 to 8 is when you start to see a color change from yellow to blue. So depending which range I'm looking for, I could actually get a color change either around 2.5 or 3, or up here around 8. Methyl orange is changing right here around 4. Bromophenol blue has a nice green color in the middle of it, but it's very low. If I go to bromothiamol blue, I get that same green color, but it's right here around this pH of 7. So this is a very common indicator used for titrations. Another one that's very common is this phenolphthalein, because it turns from clear to pink, which is a very, very sharp change. It's very instant, very sharp. You'll see that color change immediately if you're doing a titration. And it is a little above. It's more like a pH of 8 than a pH of 7. But if you'll notice how fast this is changing from pH 8 to pH 7, might only be 1 drop difference from your burette. So there might even be half a drop difference. It really doesn't affect the calculation significantly. So if I'm trying to do a titration, the goal of this is to actually figure out what the unknown acid or unknown base is. I'm going to use the equivalence point. Assume that the equivalence point, this is what you're looking for. The OH minus concentration equals the H3O plus concentration. Now, I know molarity is moles per liter. M equals N over V. I want to write it out a little nicer. I can solve and find out how many moles that I've added. This would be the moles of the known solution that you added to the unknown. Because I know the volume that I added, and I know the molarity of the known one. Now I'm going to say that N of H3O is equal to N of OH. I can replace N with M times V because this can get plugged in directly to this. Okay? Because N equals M times V. And I use the following equation then. So this red equation, this is the derived equation that you want to use. Write this down. Just be aware that if I have a monoprotic, something like HCl is monoprotic. There's only one hydrogen when I do this. But if I have a diprotic, something like H2SO4, for that to completely dissociate, you're going to get 2 of the H3O pluses. So I would have to multiply this concentration by 2 to fit into here. Okay, there's 2 H3O pluses for every molar concentration of H2SO4. So we'll go over a couple of these practice problems in class tomorrow, and I will show you how to actually demonstrate an actual titration for you, and we'll get you guys started with computer simulation and seeing how to use some of this stuff. But again, titrations, there's some things you have to write down and know. One of those is that reaction, and another thing is some of this definitions that you have to have written down.